Okay, so in the last video we were wrapping up pulleys. So as you make these pulley systems more and more complex, the more and more mechanical advantage you'll get. The easier and easier it would be to lift your object. So if you add something like something you would have seen in class, if we would have had the chance to do the labs, we could have had this system of 6 pulleys trying to lift my object. Okay, so a set of 3 fixed pulleys and 3 movable pulleys. And if I attach my rope here and feed it around my pulley system, okay, so I get to stand down here on the ground, pulling on this rope here to help my object move, but I get the help of 1, 2, 3, 4, 5, 6 ropes helping me pull up. Okay, so I get a lot more mechanical advantage, and with the mechanical advantage of 6. So in terms of my distance, it's going to take me 6 times the distance of pulling to get the object to move, but it'll take 1/6 the force. So that's mechanical advantage of pulleys. There we go. Do this layer. Alright, so next, incline planes, aka a ramp. So an incline plane, a ramp, yay, triangles again. So in this case, a little different than pulleys or levers, I have some object that I'm going to push up this ramp. Now, the direction I need to move it is all the way up the ramp. So this is going to be my distance in. My input distance is the distance I move it along the ramp. Now, I guess in reality I should probably make it the whole length of the ramp. I had to start from the ground and I'm pushing it up this way. My output distance is the height I need the object to go. This is going to be my distance out. So again, mechanical advantage is equal to my distance in divided by my distance out. So the length of my ramp divided by the height of my ramp gives me the mechanical advantage, which is also equal to the force out divided by the force in. Now, the amount of force you're pushing on this box is a little bit harder to figure out unless you have a force meter and you're measuring it. But what I can figure out, because we've done this a lot before, is the force of gravity on that object. That's going to equal my force out. Okay, and remember in class before we did things with different color here. You know, we did the normal force, and we used the angles of the ramp and figured out this part here. Yeah. We might need to do that at some point here, but that's not what we're worried about for mechanical advantage of an inclined plane. All you need is your output force, which is the force of gravity pulling the box down, the distance, the height you want it to go, and the length of the ramp, and then you can use that to solve for your input force, how much force you have to push with. For things like screws, wedges, wheel and axle, with a screw, there we go. With a screw, we have this thing here, and it has threads on it. Mechanical advantage is related to the, I think it's the circumference of the screw. and the distance between the threads. Don't plan on getting that far into it with you guys. Most of our stuff is going to stick to pulleys, levers, and ramps. Screw, wedge, wheel, and axle. I'll continue looking through the packet, but if that comes up, I'll make a video about it. Wheel and axle is related to torque. You have the axle, the small part in here, and then the wheel on the outside. So the torque on this part related to this part has to do with mechanical advantage there. And again, we'll get into that if necessary. But hopefully that helps with a lot of the homework questions and problems. They really focus on mechanical advantage. If you have any other questions, please let me know.